Okay, for homework 321, what I'd like you to really do is try these 4 sets of problems, try them on your own, and then look at my key here, which I'm going to show you to see how you did. Really test your learning. Try these on your own first, but then go back and look at your work compared against mine, or at the very least, write down the work I'm doing and the 5 words to show me that you listen. Here we go. So these are equivalent or not. I'm doing adjustments to my equations. If I'm doing the proper adjustments, they will stay equivalent. If I'm looking at this first one right here, it looks like I'm timesing that first top row. Looks like I'm timesing by 2. If I get my pen to work. So everything by 2. Which means I'm taking that top row and timesing every number by 2. 2x, 2 times y, and 2 times 120 to get 240. Since that's all the way through, and that bottom one is exactly the same, I'm going to say that one is a yes. If I was to distribute that first one all the way by 2, that would give me that 2x plus 2y equal to 240. And of course, that last one, since it remains unchanged, that one would be yes, those are equivalent. Even though they look different, they are the same. This bottom one here, next one, looks like the top row remained unchanged, but that's that bottom row being times by -1 all the way through. So -1 times x, -1 times -3, positive 3y, -1 all the way down times that negative, or times that 50 gives me -50. Because I'm multiplying all the way through every single term in there by -1, that keeps it equivalent. If I did every term except for that last one, no good. All right, let's look at these next two. This one says 2x plus 2y equal 240 if I'm timesing by 2. The bottom one says times by -1, and it looks like that one is all the way good until I forget to make this 50 negative. So since that's the case, this one would be a no, not equivalent, because I didn't times that all the way through. If that would have been -x plus 3y right there minus 50, that would have been a yes, but since that's not there, that's a no. All right, look at the next one here. Next one, kind of silly, not sure why I gave it to you, but the way this one's set up, both of them are the same. That would be a yes. First word is red. Red. Here, I'd like you to write down another scenario that would be a no. That would be one that times the top row all the way through by 2, but left that 120 alone. That would have to be 2x plus 2y equal 240 for that one to be equivalent. But since I'm having you write this right here, because I did not times all the way through, and I left that 120 right there instead of 240, that makes this one another no. So if you could add that into that little column right there. All right, let's keep going. These problems, you're plugging in the numbers and seeing which one gives you the same y number. I would shy away from these threes, because these threes are not a factor of this 5 down here. If you were to plug in a 3 for x in those, you would be dealing with a fraction. But those other numbers, if you plug in a 5, you'll be dealing with no fractions. So here I go. Let's see what I get when I take that first one and plug in 5. So if I take that first equation, plug in 5 for x, what happens is these 5's will cancel really and leave me just that -3. Or I could have got -15 over 5 as another way to get -3. But no matter what, that 3/5 negative times 5 ends up being -3. And then when I add that to 1, I'm sorry, -3 plus 2, that gives me -1, which means technically when I plugged in that 5, the y number that got spit out is -1. So let's see what happens when I plug in that 5 into my second equation. So that second equation, let's see, I got my 1/5 right there. I'm going to plug in my 5 for x on this one, -2. That gives me 1 minus 2, and if I did this correctly, that is another -1. So you could see for that bottom equation, when I plugged in that same 5, it gave me -1 for y. So that's the magic pair. None of these other ones would have worked, I promise. So the x value was 5 to make this combination work, and the y number is -1. That's the magic pair. When I plugged in 5 for x into both equations, plugged in this 5 right here, it both spit out -1 for y. All right, second word is shoe. Shoe. All right, this one, the system one. So I'm going to have you write your own system of equations. So I got 8a plus 5b equals 33.5. I got 7a, 3b equals 24.5. I'm going to take that top row and times by -7. And I didn't mean this problem to shake out like this, but it is what it is. And that bottom row, I'm going to times by +8. And the reason I'm doing that is that will give me that -56 term I'm looking for and another 56 term underneath it. I'm doing that to eliminate my A's. If I do that, my A's will cancel. And here's what happens. That top row becomes -56a. Let's write that right here. -56a. -7 times 5 gives me -35b. And then -7 times that 33.5, let's use my calculator, gives me -234.5. That bottom row, +56a. Again, that will cancel my a's. 8 times 3, 24b. And then 8 all the way down times that 24.5 gives me +196. If I do this properly, I should end up with a nice, neat answer. So these go away. -35 minus 24, or 35 negative and +24, give me -11b. -234.5 plus 196 gives me -38.5. When I divide by -11, hopefully it gives me a nice, neat number. Gives me 3.5. When I plug that in, let's plug that into the top one. I'm going to solve for A now. So I take that 8A, where that 5 and that B is, I plug that 3.5 for B. Gives me 8A plus 5 times 3.5 gives me 17.5. Take away 17.5 on both sides. Gives me 8A equals 16. And if I divide by 8, there's my second nice, neat number, 2. All right, but remember on this one, can't just stop right there. You need to explain what those answers mean. And here's what I want. I want A, 2. I want you to realize that's $2 for every 1 apple. That's the unit rate price per apple. The B number is the price per banana. $3.50 for every 1 banana. That is a unit rate for banana. So solving for A and B, you're getting the unit rate price for apples and the price for bananas. Third word is black. Black. All right, here we go. Next, this last one here that we did today. Again, write the equation of this line. So if I look at it, again, trying to get you ready. This is going over 3, down 1, but be careful. That's not 3 over negative 1. Super common mistake. That is rise over run. That's negative 1 over 3. If I was to write that equation of that blue line, that's y equals negative 1/3 x plus 5. What I'm looking for in that list are pretty much two things. One of those equations with the same number in front of x. The fourth word is shirt. Shirt. If it has the same number in front of x, that means you have a parallel line situation, which is this one right here. So label that one parallel. They both have the same number in front of x. If I was to graph that, that would start at 2 and do that same over 3 down 1 pattern. Makes it parallel. Same slope, but different y-intercepts. That's the line y equals negative 1/3 x plus 2. So same slope, different y-intercepts. The other one I'm looking for is called perpendicular, and that's when they form a 90-degree angle, don't have the same slope. And that rule is for a line to have perpendicular slope, you take the opposite reciprocal, which means you flip-flop the original slope you're trying to compare it to, but then not just flip-flop, but opposite flip-flop, opposite reciprocal. So the opposite of negative 1/3 is positive. So that opposite reciprocal slope is going to be 3. The opposite reciprocal of negative 1/3 is 3 over 1, which means I'm looking for a slope that has 3 in front of it. And I can see right here, this is the only one that is technically perpendicular. It has a 3 in front of its x. If I was to graph that perpendicular line, it would start here at 2, but then go over 1, up 3, over 1, up 3. That green line going over 1, up 3 forms a perfect 90-degree perpendicular angle to the line it's cutting across. The other scenario is this: if it's not equal, or if it's not the opposite reciprocal, then it's neither. Because any graph that does not have the same slope is not parallel. Any graph that does not have the exact opposite reciprocal is neither. If I was to graph negative 3x plus 2, that would look like this. And you could see negative 3x plus 2 is no way perpendicular to that blue line. Nope, that's just a nothing line, maybe a one solution line. All right, the fifth word is green. Green. So check your work against mine. Write down those 5 words. Good luck. See you tomorrow.